Hello, everyone, and welcome to Handmade Hero, the show that the show that codes. That's good. The show where we code. It would be cool if the show coded itself. I guess that's more of an AI show than anything else, though, really. But the show where we code a complete game live on stream. We are coming back from last weekend when we did depth peeling in our renderer, which allowed us to do some pretty cool stuff. We basically have order-independent transparency now by doing a few depth peels, which is really cool. However, we only just barely finished that up last time, and so it's time now to kind of take a little bit of a closer look at some of it and to just go, okay, let's see, can we improve some of these things? Can we clean up some of these things? Is there anything else we want to sort of prep for in the renderer before we kind of tie it off? Because at this point, I'm getting pretty happy with it. I like sort of where it's at. So I feel like it's getting into a state where I'm okay saying, let's go ahead with the game proper because everything seems to be kind of like holding together pretty nicely. Everything could always use improvement, certainly. So there's tons and tons of things we would rather do better than we are doing them, obviously, but for the time being, everything, that's the way it is in programming all the time, right? No game ever shipped in like the history of games without the programmers being like, well, if we'd had another month, here's the things we would do, right? So programming is kind of one of those unsatisfying things in that way, which is that you're never really done. You just eventually decide that that's good enough. And you can never really get to perfect because there's always more you could be doing, usually, at least in my experience. Anyway, so let's take a look at where we're at. Today is day 383. So if you want to follow along with the programming that I'm going to do today, you want to load 382's source code into your handy editor. And let's go ahead and just remind ourselves where we are. And there's specifically, the first thing I want to take a look at is some artifacts and what we might be able to do to mitigate them or why they occur. And so I just want to kind of get us back to where we are. So we played around a little bit with some things like depth fogging and stuff, but this is the game running through the depth peeling renderer, and it's in pretty good shape. I'm pretty happy with it, and everything seems pretty nice. The problem with it at the moment, that I see anyway, is just that when you look at this from the perspective of someone who's maybe, a little bit of a stickler for artifacts, what you can see is that in certain circumstances, and it's not necessarily always trivial to get them to occur, but you can, there you go. You can see that we get some odd artifacting here where we have, like, for example, looks like where maybe there were some shadows that overlap. You can see it there, right? You can see something kind of happening there where we get these black splotches. And I don't really want to just dismiss these black splotches out of hand or, assume that there's some artifact technique because I don't really know exactly what they are. There's a number of things they could be, but they definitely have some bizarre behavior to them that warrants some further attention. And I feel like we don't really have a solid understanding at the moment of why they're occurring. So a couple things that strike me as odd about them, just to kind of give a little bit of a background as to what, why I'm a little skeptical here. So if you take a look at what's going on, it looks, where I would expect to see artifacts. I think we're doing 4 depth peels. Maybe we're doing 3. I don't remember how many, but I think we're doing 4 depth peels right now, which is a lot of depth peels, and I don't know if that's actually necessary. You can see a lot of see all those black splotches there, where you're getting just at the border there. But anyway, look at all those particles are generating those black splotches at this layer. So the thing that's really weird about that is it feels to me like that maybe is some kind of an overflow color bug or something like this, and not a depth peeling bug or something. Or it's like a 2 Z's are being equal or something bug. I don't know. But basically, I feel like there is evidence that this is just a straight up bug and not a limitation of our technique. And the reason for that is obviously the solid black color. It's not changing at all. It's just a perfect black, so it's almost like it is drawing something with an overflowed color value or an underflowed color value instead of the alpha being properly 0 or something. It's showing up as black, right? And so I feel like maybe our technique is actually better than this, and the shader is just wrong, and it's not clamping something that it actually needs to clamp, or something, right? The other thing that could be happening there, and again, like I said, I don't know, is we don't have a solid argument right now for what happens when two things occupy the same Z position in our depth field. One of them will get thrown away arbitrarily in that case, I think. I'm not 100% certain exactly what will happen in that case. But when two things are at exactly the same Z, I don't really know that we handle that exactly properly. Now, again, though, that I can't say I can think at the moment anyway of why that would be like I just don't know why that would be pure black as the result, right? I would think that I would get like flickering or something as a result of that, as the draw order changed, or something. But pure black, again, I can't get there in my head. Like I can't rationalize why we would be seeing pure black with this technique, which makes me think something else is up that I don't understand yet, right? That I haven't investigated correctly, and also, most of the time, I feel like it's just good policy to investigate artifacts with an open mind and don't assume that you know what the artifact is, because unless it's glaringly obvious, you might miss something in the code that's wrong when you go to like say, oh, this is why this artifact is happening, right? Okay, so, just trying to figure out what the situation is here. I want to take a gander kind of at how we're doing things like our peel compositing, for example. I want to make sure that we can't overflow a color value, for example. And so one thing I could do, right, is I could come through here and I could try to I could try to analyze it very carefully and so on and so forth. But it looks like at the moment anyway. Oh, that's good. I like how we have a times here, not a times equals. I was going to say that's not right at all. That's supposed to be a times equals inverse A. But okay. So when we're adding things together here, right, just looking at this, it seems like there's really not a lot of ways that this can go wrong. You know what I'm saying? We've got 4 color values here. And so if we assume that the previous stage worked, which again we have to verify that it actually did because we don't know if it did or not, but assuming that the previous stage worked, we look at these color values and we say, okay, we're going to add these color values here, and we're going to add them at the inverse of whatever their alpha is, right? So if we take a look at how we're blending stuff in here, right, it looks like that would be pretty safe from overflows. Because we're always using 1 minus the alpha and the alpha, so we can't sum to greater than 1, right? However, that assumes that the alpha value was properly pre-multiplied in, right? It assumes that peel 0, 1, and 2 all have their alpha values pre-multiplied into their color values. So if we weren't pre-multiplying here, that would definitely give us the possibility of overflowing our color values. Now, we can start fiddling with this. Like I could multiply this by its alpha values on this side to ensure that that wasn't the case, and then we would get perhaps incorrect color mixing if they were, but we wouldn't necessarily see black. However, what I'm going to do instead is just see whether this is an overflow by clamping the color values, right? Just so I can get some semblance of knowing whether or not I overflowed, so I can eliminate that you know, creating an out of bounds value as the reason that we were seeing black in a situation where maybe we shouldn't have. So I'm going to go ahead and say GLSL 3.0 quick reference card, as we normally use on the stream for looking up the function names. So there's a function that will clamp things for us, and this is it, right? You can kind of see here, I'll zoom in so you can get a better view of that. There we go. So you can see here we've got a variety of functions that we can use to clamp things. And you can see that they basically take the form, here's the thing I'm going to clamp, here's the minimum value, here's the maximum value. And you can kind of do that in a number of different, with a number of different data types, but it's basically the same thing. So what I'm going to do is I'm going to say I want to clamp, oops, it's lowercase, I want to clamp that result color. So I'm going to pass the result color in, and I just want to clamp it between 0 and 1, and that's all I want to do. And so again, all I'm trying to do here is verify that I didn't get any kind of weird problem where I am, you know, where I'm overshooting the color values. And that was really kind of interesting there, wasn't it? The background changed, which again is kind of a red flag for me there. So looking at it, though, that did not in any way improve our situation. You can kind of see here that we still have some very strange values going on. So you can see, you can kind of see there we got the fringing happening. However, we also get white fringing, which is really interesting too, showing through that gray value. That's very strange. So clamping the color value between 0 and 1, I'm not sure I understand why that would have changed our background color at all, right? Because the background color wasn't out of range in that way. I'm wondering if I did something odd here that I shouldn't have done. I don't think there's, you know, as far as I know, clamp with a vector just clamps the individual components. So I don't think there's any difference between writing what I just wrote and writing this, but I'll check. And the min and max values should be 0 to 1. That should be our color range that we're outputting. As far as I know, we should not be outputting anything else. We should always be staying in that range entirely. So I don't really know what's going on there. That's awfully suspicious. Yeah, that's... I really don't know why that's happening. So I literally have no idea why that's happening. I want to change the alpha value to just be 1 here, because I'm interested to know if there's any sort of play with, if the alpha has anything to do with it. And it doesn't really look like it. So the clamping on the background color appears to be from the R, G, and B getting clamped. So when there's only a peel 3, that's the thing that's getting clamped somehow. How, I do not know. So let's take a look if that's correct. So if I look at peel 3, which should just be the background, anywhere that you can see just the background. So this is the background here. And I don't have any idea like how that's looking black like that. So let's see what happens if I don't clamp, and instead of clamping, I just pass the R, the G, and the B values here like so. So there's my R, G, and B values from PL3. So even just straight assigning those, I don't get what I would expect. So that's really strange. So what happens if I look at PL2 instead, in this case? I must be really out to lunch here, because I have no idea why this is happening. So all of these appear to be black. So I think that is very interesting and possibly has to do with our problem. I have no idea how that clamp is resulting in that, but it does suggest to me that the peels are not having their destination alpha and their color set properly, I guess, because peel 3, at the very least, anywhere where there isn't anything, should be precisely the background color. So let's see if we can figure out what's going on here. I'm going to say that result color... well, here's another thing I can do. So we've got this inverse alpha offset thing here. Let's stop doing that as well. So let's see what peel 3 ends up being. Because peel 2 we would expect to be black, because peel 2 is supposed to be pre-multiplied alpha, right? So that makes sense. But peel 3 is supposed to be gray. Okay, so it looks like that alpha inverse computation is just wrong. So we've got our peel 3 here. It's multiplying by the inverse of its alpha, and somehow getting a totally wrong result there. Black, I guess. Oh, you know what? So that actually does make sense now that I look at how I wrote this. So the problem there, right, is if the peel 3 alpha is actually equal to 0, then we will multiply by 0, right? But I guess what we really wanted to multiply by, in this case, was 1. And you know what? I think we may want to remove this anyway, because I feel like the other thing I wanted to do today was make it so that peel 3 didn't ever have alpha in it at all. All right, so let's see here. Let me get rid of this just for a moment. And so now we are able to see that gray, I suspect, right? If I say result color equals peel 3, we should see that gray background. Yeah. All right. So that's all fine. So now we're back to the same question we had before, though, which is where is that weird sort of fringing coming from? But at least we kind of have that other part there under control. All right. So now let me see if I can put my clamp back in and get what I expected to get when I originally put it in. So now we can see that since I'm clamping that, at least in theory, those black splotches are not coming from a color overflow here, right? They may still be being caused by something overflowing or something happening somewhere else, but this particular part of the compositing is not the problem, right? Let me put it to do here. So now we're kind of left with a question of how do we get solid black at all, right? So what I am trying to determine is if peel 3 is going to be written directly, right? And we kind of know, I mean, I guess it's a little bit hard to say because we don't really know. Well, okay, here's what we could do. So let's suppose we colored these peels based on where they are. So we'll set each individual peel to a specific color so we can see which peels are which, right? So what I'm going to do is I'm going to say that peel 0 is going to be our blue peel, and then we get, to our red peel is peel, it's going to be blue, green, red is the third one back, and then, maybe I'll do yellow is the third one back, and then red is the final peel, right? And so what we want to see here is we should be able to look at the screen and see what sort of peels we're using in any particular, place, right? And actually, what I should do is change this a little bit. So what I'm going to do is I'm going to put an if 0 here around the real code. I'm actually going to go ahead and do this as an if, I think. So I'm going to do something like trying to think if there's any way I can get that third peel to be anything in particular. We just have one more peel than we have colors to work with here. So let's try this. Let's get rid of peel 3 for the moment, I guess. And we'll just use the standard composite, but we'll do it with red, green, and blue assigned to the different peels. And now what we should be able to do is look at the color of an individual pixel and see what the contribution of each peel is by how much of each channel there is in it, right? So when you look at the screen now, what you can see is the overwhelming majority of the screen is blue, and that makes sense because that's the frontmost peel, right? And what you can see, basically, when you get to 2, like when you're looking at shadows, for example, or when you're looking at a couple different overlapping heads, what you can see there is you can see that it becomes cyan, which means that peel 2 is also contributing, which is, again, exactly what we'd expect. And where you see white, white means that either we have all the peels contributing or we have 3 of the peels contributing. Unfortunately, we can't really tell the difference between peel 2 contributing and peel 2 and 3 contributing, because we don't have another color channel for peel 3. I wish we did. Okay, so what we can see here is I think we can at least identify where those black splotches were. Are definitely where are definitely where we had a lot of overlapping peels. Let me also do this. Let me multiply each one of these by its alpha correctly. Like so. And that way I can also, if peel 0 is non-contributing, we won't see it, right? So that's kind of odd. I think did I mess that up? So that suggests to me again that there's something weird going on here, because take a look up here, right? That should just be blue because it's pretty much a frontmost thing. And if we turn off this shader, we don't see, what we're looking at there is we see that we're supposed to be seeing the second depth peel is primal, but I don't know why that would be the case. Oh, I do know. Okay, no, that's actually correct. So that's where the shadow of this tree is. And this tree, which is actually getting drawn behind it, is the second depth peel. And so it is, it is showing itself through because the shadow was what was behind it. And then where the 2 shadows are, that's where we get that red. So that's okay. That all makes reasonable sense, actually. So now if we look at what we're seeing here, it's pretty clear that the place where we get the error is where we have lots of peels overlapping, right? So you can see we get sort of these depth peels happening here. What's interesting is something feels off about this because these values seem to have faded out entirely from alpha. I mean, maybe they're just really low, but it seems like they've faded out almost entirely, and yet this is depth peel 3 at this point. But Are there really two things that are alpha'd out there? That seems a little bit strange to me. It seems like our fogging is not able to get the alpha to go quite to 0. But that front clip plane should be doing that. So it's a little bit strange. So we take a look at what's happening here. We've got our code here for how we're doing our alpha, right? And you can see us modifying the output fragment color by the fog distance here by doing a clamped range map. And in theory, you know, that 0, when we get zeros there, that should kill it. I'm interested to know what happens if I increase our threshold a little bit and say, let's kill things a little prematurely, right? Let's kill things a little bit before their alpha value actually gets to 0. And let me see what happens there with those red values. See, that's just really suspicious, right? That does not make sense to me. Because now I'm killing at 0.1 alpha. And how am I seeing this at all without something in front of it at that point? Like, why is that thing on depth PL3 if I can't see anything in front of it? If the alpha gets clamped off at 0.1, that just doesn't make any sense, right? If the alpha is getting clamped off at 0.1, something's busted. I say. I mean, let's go even further. Let's say that the alpha has to be extreme. Like, you've got to be half visible, or we will not show you. Now what happens? Same thing, right? So this concerns me quite a bit, right? Like, something's happening that I don't understand for sure. Because unless I really have it wrong, if I'm saying that the texture, okay. I see now. This is the problem right here. This is the problem all along. So the texture sample is just the texture color. So we're not discarding on alpha anymore. We forgot to do that. We need to move the mod color up. And we need to compute that right here. So we need to take the texture sample and we need to do the multiply, right? To figure that out. Now, I don't really know how the shader compiler will probably reorganize the scalar stuff in here. So I'm guessing that really all I want to do is do this outside. So, because, you know, at the end of the day, the shaders have to execute everything in parallel anyway, so it can only early out in some certain circumstances. So I'm going to just move those before the if. And here I'm going to load that texture sample, do the sRGB fix-up if we need to, compute that mod color, and then I'm going to talk about mod color alpha. So now with mod color alpha, we're actually taking that fog into account. See, we were fogging things out, but then we weren't taking them out of the depth peel, and that's just totally wrong. You know what I'm saying? So now those should not be perfect. Okay, perfect. So that was really stressing our depth peeling out in a way that it never should have. So let's take a look if this improves our situation at all. in the case where we are clipping alpha normally. So now let's take a look at what happens in there. And now it's looking a lot better, right, in there. And I don't know if it's good enough, but it's definitely looking better. So let's take a quick peek back at the rendered version just to see where we're at in those terms, right? So now let's go ahead and we'll hop down here like so. And so now you can see we've really mitigated it quite a bit. It still happens a little. You can see it happening right there, just at that changeover point, right? Where I guess we've got too many things alpha'd up on top of each other. I'm not entirely sure, right, exactly what's causing that, but it's pretty close. You know what I'm saying? It's getting pretty close. Okay. So the only problem now that we have, besides the fact that we still have a little bit of that artifact there, is that I still am not 100% confident I know what the artifact actually is, right? And so that's the reason I originally started this investigation, is not just to fix it, but to figure out what I'm not understanding properly. So I now have some information, which is it is a place where there are a lot of depth peels. And so what I'm wondering is, I guess, is that just a place where there's too many depth peels, so the bottommost depth peel is not enough information? Or something like that? I'm not sure. So I'm going to propose another test that we should do here, which is to see where we're seeing the final depth peel. So to do that, what I want to do is I want to say basically peel 3 in all cases is going to be, bright pink, right? So I can see where the final depth peel shows through. So as I'm hopping around here, I could see that the hero actually sees the final depth peel where it's got a lot of things stacked on top of each other, actually. But otherwise, it's pretty much just the background. Now what I'm expecting to see is when I come through here, I should see purple at the place where we flash. And yes, we do, right? You can see that purple there. So that seems like we just have too many depth peels, or sorry, too few depth peels for the level of complexity that we're looking at, depth complexity. But I'm really not sure. So a couple things we could do here, right? One thing that we can do here is we could say, well, let's just increase the number of depth peels, right? We always depth peel till we get something. But the problem with that is it has this nasty failure case of like, well, when things just keep stacking up on top of each other, eventually we're going to fail, right? So what we'd rather do is have it so that once we get to a number of things stacked on top of each other like that, we are, we're going to degrade more gracefully. Now, one of the things I would point out in that situation is by the time you get to 4 depth peels, you can't perceive the results very accurately at that point. The person looking at it. You're blending 4 layers together. At that point, it seems to me like that's just excessive, right? because the visual fidelity at that point for you is not good enough. It's not going to be good enough to really perceive how that blend is being done. So it feels to me like what you probably would want to do there is produce something that's going to properly average things together. Or I shouldn't say properly. Produce something that, like, say, depth peel 3 is always an opaque background color. That is whatever however far back we had to go to get something opaque. So, pass 1 is the closest thing. Pass 0 is the closest opaque thing. And then, like, in the middle is just a averaging together of their results or something. You know what I mean? So, like, in between is all the things that are alpha'd, and they're just averaged together by their alpha or something like this. Do you know what I mean? Because essentially what we know is, when we've got things stacked on top of each other, we're always going to have a situation where that fundamentally looks like this. There's going to be an opaque color, even if that's just the background color, but it's whatever the last solid object was, right? And then there's going to be the frontmost pixel, right? And then in here, there's just a bunch of alpha'd stuff. Because if it wasn't alpha'd, we don't need to keep depth peeling, right? If it wasn't alpha'd, you're never going to see what's behind it. So we always have between 0 and n alpha'd things in the middle, and we've got a front and a back that kind of sandwich them together, right? This is presumably the most important thing usually, unless its alpha gets really low. But then all these are averaged together or whatever, and then we've got this, opaque thing. So I'm wondering if we could do something where we just mix everything together in here or something like that, and then guarantee that we always get one opaque thing back here, and then, composite those together. And basically what that would mean is, right now the way we composite things together in alpha blending, in the alpha blending world, is we say something like, well, we've got like a front and a back, right? We've got the thing that's like in front of and the thing that's behind. And we're going to blend those together. So typically what we do is we say, well, the alpha value of the front times itself plus 1 minus the alpha value of the front, and I could be more specific about that, times the back is how I cover. This is like, on top of, I think, is how it's normally described in terms of what the shading operation is. It's like I'm going to put this on top of that, right? So as the alpha of this fades out, I get, more of this and vice versa. Now, we could choose to mix things together in a way that doesn't have an order dependence to it, right? We could choose to mix things together by saying, all right, what if we just did, AF plus BF, I'm sorry, AF plus AB, right? So we took the alpha from the front, multiplied it by the front, took the alpha from the back, multiplied it by the back, right? Which is what we're doing. Accumulate these together into something to produce basically an average, right? If we just average things together. And we just accumulate these things together and then normalize at the end. So instead of, two 8-bit per channel frame buffers that we accumulate into, we'd have two 16 bits per channel frame buffers or something like this that we would accumulate into, and then we would renormalize at the end, right? Now, I don't know if that really makes a lot of sense, because it severely limits the kinds of effects we can do with our alpha. So it's a little hard to say. I'm just not sure. It's obviously not as good as depth peeling in terms of getting that coverage correct, but it's something to consider, or perhaps something to just try and see what it does. However, that said, again, I still want to make sure that I actually understand this correctly. And so let's see if we can try to figure out what's actually happening here in terms of where the bug part comes from. So let's switch back to the regular view. And so as I come through here, I want to be able to see that glitch. It's really kind of hard to see the glitch now. But you know, I can kind of get between it there. There's no real frame that I can find that I can hold on it, unfortunately. Maybe if well, probably won't, but I'll try hopping down one more flight of stairs, because maybe that'll work. Yeah, I unfortunately can't quite get it to reproduce that. Well, it would be nice if we get to reproduce that. Maybe I should add some kind of a pause, or because you know, I can use the debug camera, but then fogging is turned off on the debug camera, unfortunately. So I guess I could turn fogging on for the debug camera, but the whole point of the debug camera is so that we can inspect things. So typically I have it turn the fog off, so we can see the status of things, right? But yeah, we know that those areas are the regions where we're seeing peel 3 earlier, right? We're running out of depth peels. And so I guess the problem is, you know, if I had to sort of hand wave it here, the problem is that there's too many things overlapping this area. And because there's too many things overlapping that area, what that means is that you never get to the background gray color. So even though, you know, somebody in the background there has an alpha value that's actually fairly low, and you should be seeing a fair bit of gray through it, there is no gray coming in because peel 3 is still alpha'd out, right? So I wonder, you know, one thing we could try is just sort of a simpler version of the scheme I outlined, which is saying, well, let's do our depth peeling, but let's make sure we always get eventually back to an opaque color. You know? And maybe that helps reduce those artifacts. You know, I don't know, maybe it'll just introduce different artifacts, but I'm just interested to know, like, what if we had our depth peel you know, do something where it would be able to throw out things based on a programmatic alpha. So for example, here's the fragment shader, and you know, I've got some stuff in here like the fog color that's coming in from the outside. I'm going to introduce another one, which is just an F32. That's the min alpha value, right? And maybe I want to do that a little bit differently. Maybe I want to do that and say that it's the, well, because I want to make it have to be exactly 1. So I guess maybe I don't really want to do that. Maybe I want 2 different versions of the shader. I don't know. Because basically what I want to do is I want to change this line so that instead of mod color A is greater than 0, what I want to do is create it to be equal to 1, right? But, you know, I don't know, maybe that's too aggressive. Maybe what I really want to do is just make it so that that's actually just some high number. All right, well, let's do that. Let's just say we do F32, which is just going to be an alpha threshold. And the alpha threshold value is just going to be the thing that we use to clip. So it'll be 0 on the first couple depth peels, but then the final depth peel will jack it up to something high. So we're only going to record into that final depth peel. We're going to skip anybody who might have been in front, but just who had an alpha threshold that was just simply too low. Right? So I'm going to go in here and just make sure that we can actually get that value. So here's our z-bias program. I'm going to add it here to alpha threshold. And I need to grab it at some point as well. So that'll get us the location of it, and then all we need to do is set it. And so up here, when we're doing that peeling stuff, basically what we want to do is say, well, OK, let's take a look at the peel index, and we want to set this based on that. So what I want to do is, when we do use program begin here, after that, let's see here, we've got that. Here's our use program begin with the render setup passed to it for the z-bias program. What I want to do here is pass in the alpha threshold. And now, anywhere that we're using that, which of course is only one place, we have to pass an alpha threshold. And so what I want to do here is I want to pass the alpha threshold based on the peel configuration. So basically, the alpha threshold is always going to be 0 for pretty much all cases, except the case where the where we are doing peeling, right? In fact, I could do it like this. Where we are doing peeling, and we're on the last peel. So at that point, maybe we say it's got to be, 0.9. I don't know. I'm making this number up. So we are peeling, and then we want to say, oh, is the peel index, the last peel, right? So is peel index equal to max render target index? So we know that we're basically done. And this is the last peel we're going to get. All right. So now what we're doing is we're basically saying, hey, we're trying to produce a final layer that will always have something in it, right? And we'll see if that helps with those artifacts at all. So it definitely helped. But I still see a little minor little artifacts, like right here. You can see one there, right? It's really pretty minimal, but it's definitely still there. And let's also see whether we can get. We were having those artifacts when one of the snakes would come by and all those particles were raining down. I don't know how to get the snake to do that again. There they are. Hopefully the snake will come do that again. It doesn't seem like it wants to at the moment, but. So the question is, yeah, will we get any there? There I'm seeing some raining down, and I'm not seeing any artifacts on those now. So it seems like that is a pretty effective fix for the vast majority of the artifacting, actually, which is pretty nice. Oh, the snake came down the stairs. So that's good. There the snake goes. Now we got 2 snakes. All right, maybe I'll go down the stairs one more time, because if there's 2 snakes on this level, that should produce a lot of particles that will rain down to the floor below. Oops, I gotta go up 1, don't I? How do I get up 1? Do I get up like that? Okay. So that's a very effective fix for a lot of those artifacts. Again, I still see it a little bit in certain circumstances, but it's pretty darn good. So yeah, I'm trying to think if there's anything else I should do here that would help. So I guess the other thing is, if we always know that that background alpha is going to be something high, right? And I feel like when we clear it, it should have been cleared to an alpha value of 1 as well, or at least I hope that it was. I don't know if it was or not. So let's actually see what we're doing there. Like, so this kind of has to be 1.0 now. So if that alpha value is 1, then that means that in the shader, there is no way to ever have an alpha value that isn't high, because nothing would get drawn if it wasn't. So in theory, we should also be able to undo any pre-multiplied alpha that's happening. So that should now work, and we shouldn't see any bugs from it, I don't think. In fact, you should be able to do this directly. So basically undoing the pre-multiplied alpha, where we're just going to, multiply the RGB by the inverse of the alpha to un-pre-multiply, if that makes sense. So that actually looks worse, which suggests to me that maybe the pre-multiplication of the alpha isn't happening properly or something. I'm not 100% certain what's going on with that. So like if we look in here, excuse me. Here's the thing that produces all of our fragment code. So we're fetching our texture sample, and our texture samples are pre-multiplied alpha, or at least they are supposed to be, right? Now, there is one problem that we have here, and this could be the kind of place where it actually does matter. The problem that we have is that our bundler, our art asset packer, doesn't properly handle sRGB. It was made for the old renderer, which just uses squares and square roots. So the problem we then get is that means that our alpha is always a little bit wrong. Because, well, the pre-multiplication of the alpha is a little bit wrong. Because instead of pre-multiplying by the correct alpha, we're actually pre-multiplying by a slightly different instead of pre-multiplying the sRGB corrected colors and storing those, we're pre-multiplying squared colors and multiplying those, right? Which is not the right thing when then the card does an sRGB correction. I don't know that that would show up in this situation, but it's worth remembering that it's on the table, because when you're getting down to little artifacts, you have to be thinking of everything. But anyway, so when we do the texture samples here, we produce a mod color. We then go ahead and you can see here, we then kind of go ahead and take the fragment color and multiply by the text sample. Now, here's this is doing pre-multiplication properly here, right? There's the frag color. The entire thing is being multiplied by the alpha amount that's coming out of the fog. There, fog itself, of course, is not handled that way, but that's okay. We don't really need it to be handled that way. So that's fine. I am curious, was there a reason? There must have been a reason, but I don't remember what it was. What was the reason why we didn't use the fragment color to do the fogging? Oh, right. Because since it's clamped... Actually, that's an interesting point. Since these values are clamped, they really can't be done in a vertex shader, can they? Like, isn't this kind of wrong? Because if you clamp something, it will be wrong if it's done at the vertex level if the pixels don't all have the same values as the vertices of the things you're clamping on, right? So I feel like that's actually not right. I feel like that actually has to get done in the pixel shader. Wouldn't you guys agree? I feel like that's... I feel like that's just kind of true. So I feel like what we can do is we can do the fog distance computation. We can definitely do the fog distance computation, but I don't think we can actually do these. Like, I think these have to be done down here, to be completely honest. Right? I think this stuff has to happen here. Because, correct me if I'm wrong, if you think about what's going on, we've got some sprites or whatever, and we've got maybe some fog. So let's say the fog is going this way. Well, if the fog max value is like, you know, this line or whatever, right? Then if I clamp these values, they're wrong, right? Because I'm going to interpolate along this thing, and I want to get the max. I want to go from the min to the max here. But if I'm clamping these, I'll actually go from the min to the max over this entire thing, because the pixel shader will interpolate it between those endpoints. So, so I don't think that's correct. I don't think that's correct at all. So I think what we can do is say that there's a smooth out F32 fog distance. But I think that's all we can do. And then I think this stuff has to be computed here. I think this stuff has to be computed. And so the start and end distances, like this stuff, has to get looked up. Right? And so I just want to make sure everyone kind of understands what I'm talking about. And again, I'm not claiming that I'm right here. This is just what I was looking at. I was like, this doesn't seem right. Essentially, you know, we've got two parts of the pipeline, right? There's the vertex shader, and then there's the fragment shader. And what's going to happen here is the vertex shader is only outputting things at the vertices, right? So if it wants to, it can do, you know, fog. It can do, like, you know, the point times the fog direction, right? Because that value is just going to produce a scalar that ranges over the pixels linearly. Not pixels linearly, over the triangle linearly, right? So whatever this triangle is, I can produce a value that you know, is planar in those triangles, and it'll get interpreted properly in the pixel shader, right? The pixel shader will do the perspective correction and everything correctly, and so it'll give me the right values. But I can't do something like that's going to clamp this value, right? If I start clamping this value, then what's going to happen is when it feeds to the fragment shader, it's not going to get the correct interpolated values. You know what I'm saying? So things in math that get clamped can't be specified only at the vertices because you don't know where inside the triangle it actually would have gotten clamped. So that seems like just a bug, just a straight up bug. So I think we need to be able to do this stuff here at the top of our pixel shader. Tell me what my error message is. Ooh. Okay, that's not what I wanted to see. Okay. So we're just crashing straight up inside what I assume is the compiler. That's not great. But I don't know what to do about that exactly. We're getting the fog distance in as a smooth in. So that should be correct. We've got the fog start end and the clip start and end distance. Those should be there. The fragment color that's coming in is getting multiplied by that. And then used down here. We don't really have to multiply it that way, I suppose. We could just say, hey, the alpha amount is going to modulate, the whole thing. Yeah, I don't know. I don't know what's wrong. Unfortunately, the driver is not okay. Great. So just reorganizing those things made the driver not crash. Okay. I don't know what to say. That's just how that goes, I guess. So what's interesting is now you can see the effect is totally different, actually, right? It actually looks very different now that that's happening. Very, very different. And interestingly enough, it also happens. I want to get rid of the uncorrect there because we're still doing this, which apparently is wrong, although we don't know why it's wrong yet. Also, doing it that way reduces the degree of unwanted overblending that's happening during the fade out. So it also means that we aren't getting the artifact, which is kind of a nice thing. Because not because it fixed the artifact or anything, but just because the overblending now is less. So that explains why I had to set the range up so high. We might want a little bit more of that range, though. I don't know. Like, maybe we don't. Maybe we do. I don't know. That's like tuning the effect or whatever. But yeah. So I'm really relatively happy with where we are at the moment. I think we could do more, certainly. But I'm pretty happy with that. I think that renderer is shaping up to be pretty nice. It's order independent now, uses a Z buffer for sorting. Really the only thing that's kind of stupid about it is the fact that it has to change textures so often. That's not good at all. But it's pretty nice otherwise. And we get that nice fade-in effect there, which I like. When you go up and down the levels. Particles are looking pretty good, I don't see a lot of artifacting in the particles. So, yeah, about the only thing I would say that I notice is that, if you just had, if you had a fast graphics card, I would say that probably we would want to still do multi-sampling, right? Like, let's just say you just have fill rate to burn. Then you still do get very edgy artifacts, like right along the edges there of the, of the buffer, of those sort of cube-like structures. Those lines don't get anti-aliased by anything, right? All of our bitmaps are nicely anti-aliased because the bitmaps themselves are anti-aliased. So when we blit them on and do proper bilinear filtering on them, we get a nice smooth result that doesn't have any objectionable artifacts there. We don't have at the moment any such thing for actual geometric primitives, which we are using in the case of those cubes. And so I do wonder if we want to allow a switch. I think it wouldn't be very good on this machine, but allow a switch that turns on just the whole pipeline runs through multi-sampling. Because again, somebody runs this on a GeForce Titan or something like that. There's really no reason why they shouldn't be able to get multi-sampling because it's not going to affect our pipeline at all in any way that I can think of. So if they just have fill rate lying around to light on fire, I feel like we should let them light it on fire, right? I mean, they paid for the graphics card after all, right? So what I'm wondering is if we can just turn on multi-sampling here as well. So when we create the buffers, we'll create them as multi-sampled buffers. And then at the end, we'll still do the smackdown if we need to, right? And so here we can kind of see how that would work. So we've got, this is our actual ending where we do our depth peel compositing. So this is happening here. The only change that would have to occur is this bind frame buffer call, which is currently targeting the final frame buffer, would instead have to target a temporary frame buffer, and then we would just use this exact code that we were using before, right? That's really all we would have to do. Now there's a little bit of fussing to it, because this part's going to be different. The draw region min-max part is going to be different. So there's a little bit of a difference there, but that's about it, I think. So what we should be able to do is say, like, okay, let's move this up to here, and just take a look at. Oops, that's not what I wanted to do. There we go. So this is again just the same pipeline running. So what I can do is say, well, these are the only things that would change, right? So what I could do is say if multi-sampling, oops, else, right? And so what we want to do here is say, well, I guess we don't even have to set these because they would just be always correct. So it's really just if we're not multi-sampling. Because aren't they per frame? Well, you know what? They might not be per frame. I'm going to set them either way. You never know with OpenGL. So if we're multi-sampling, I would want to do like global resolve frame buffer. And this is just going to be a temporary frame buffer that we create. It's going to have the standard dimensions. And now that I think about it, though, this is going to be a little bit more tricky than I thought it was going to be, because when we do the depth peel compositing, I don't know if shaders can automatically just use the right multi-sample index? Well, you know what? We'll just try it. We've got a half hour left. We'll just try it. And we'll see what happens. All right, so here's multi-sampling. We don't want window width and window height. What we want here is the actual like render size. So we want this. You know what I'm saying? Do we pull that out into anything ever? So I think we want to pull that out. So that we're always using the same stuff here. So there's the draw width and the draw height. And here we go. Let's see. This gets done a lot, huh? So I'm not sure. So this is interesting. So the draw region versus the command's width and height, when are those different? I thought those were always the same. So what's the difference between the window width, the window height, and the draw region? The draw region is the portion of the window we're actually drawing in. So that's actually kind of busted. The way we're doing this is a little bit wonky. I'll leave it for now, but I don't know if we really want to do it that way forever. Yeah, I wonder if we want to change the way this is being done a little bit. So if you look at the way we're doing it right now, we create frame buffer targets that are the size of the output. But I don't know whether we really want to do that. I feel like we might want to create a specific sized render and then stretch it to the screen. The reason I say that is because we might want to do stuff like, oh, we render it, 1080p on a 1080p display, so it's 1:1 and it looks nice. If you run it on a 4K display, but your graphics card can't handle 4K kinds of fill rates, then we would still render it 1080p and then stretch up to 4K is definitely what you would want to do there, right? But with the current way that we set it up, we can't do that. We're always going to render at the width and height of the actual output display, the actual size. So I feel like that's not great, Like, that just doesn't seem good. And if I remember correctly, we're actually setting this in here, right? Like, we we set this stuff up so the buffer width and height is whatever the div section is there. I don't know what we do on WM size. Nothing, apparently, right? So we're kind of doing this, right? We're kind of doing this already. And so when we set the commands, I think we're always going to be using 1920. So yeah, so I feel like what we want to do is I feel like we want to actually do that drawing correctly, the way that I suggested. Go ahead and fix that. All right, so let's just take a look at this. So we also know that we're kind of not super great right now at scaling. Like we kind of broke that like at some point there, right? So I feel like now would be a good time to just fix all that stuff because we might as well get this right for the final sort of way that the renderer is working here, which I think is pretty much where we're at. Like I think I like the step peel render. I think this is the one to go with. So let's just say that we've got sort of the draw width, the draw height here, and those are going to be the commands width and the commands height. So the actual size that everybody thinks the thing is, that's what we're going to do basically everywhere. So we create all these render targets, and we create them at whatever that size is. So the size the game thinks it's running at is the size we use. And then when we're doing render targets, again, this scissor is going to be exactly the same for everybody, for all of the targets. They're always going to be the exact same GL scissor there. And this clip scale stuff, I don't know even where that's being used right now. So yeah, I feel like that's just totally wrong because now that scale is scaling for something that we don't want to scale, right? That was stuff that was adjusting for the fact that we might be rendering directly to a screen window that was larger or smaller in pixel space than we were thinking. And so that's just not going to happen now. And so now we're always rendering to something that's the size that the game is running at, right? And so then what we have to do at the end is we have to scale down. Now, at the moment, I think that will just work. Because what's happening is we're setting the draw region now. We do the GL viewport, GL scissor bit here, and off we go. So we really just need to clear the dead area for our frame buffer, right? So we would need to do like this. So we could get black bars in there, but otherwise we should be able to now make this work a little more cleanly. So let's start getting that going. All right, so first off, this clear wants to happen over the entire thing. So the first thing we want to do is start with a full screen. So we want to do a viewport that covers everything. I don't know what window width and window height actually are, but I think they're supposed to be the whole screen, right? Oops. So this is kind of like that should clear the whole screen. And this should be more get width draw region. Like that's just wrong. We don't want the draw to the whole window. We want to draw to the part of the window we were told to draw to. Like so. And so I'm going to reclaim the word draw width here. And I want this to actually be the render width, right? Because that's a little clearer about what's going on. And then draw height is going to be render height. All right. So now we're getting somewhere. Now we properly have the sort of black bars, the letterboxing, whatever you want to call that, which we had before is happening correctly. So it keeps, maintains the aspect ratio there as you scale this around, which is what I want. But now we have to make sure that we actually do the blit to the correct size. So let's go ahead and figure out how to get that to work. And then we're in better shape here. Okay, so in here we've got that set up. You can see the viewport scissor happening here, how that's working by using the draw region that's getting passed down. And I guess I'm not sure exactly what's... So it's a little strange because with the way that this is set up, I would expect this to blip the incoming texture to the entire screen, but that's not what I'm seeing, right? So let me just... see something here. So I'm assuming that I won't see any pink when I do this. And I'm correct. So what we're doing is our actual rendering is off. It's not this dude's fault. Our actual rendering, like viewport stuff, is off. Where do we set up the viewport? Right here. So when we call OpenGL bind frame buffer, this window with window height bit is wrong. So that's why that's happening. I also don't know where we're calling bind frame buffer exactly. So here's OpenGL bind frame buffer. So basically passing the draw region for all of those is just not what we want. We just want the width and height there. So what we want to do is just have bind frame buffer take the render width and the render height. That's really what we wanted. That path really isn't supported anymore. We'll probably have to re-enable it someday when we do the software renderer update. There we go. So now we run that, and everything appears to be right here. Switch to windowed mode, and now that's nice and clean, right? Lovely. So the other thing we should now be able to do as well is if I go to Win32 Handmade, we should now be able to stretch up. So if we want to draw a smaller game, so less fill rate, use less graphics card resources, now we can, right? And so this is us doing that. Right, this is stretching up. What's interesting about that is there's some weird artifacts you get that I see there around the edges of things. I'm not sure why those are there. Only when you're stretching up. Are those there in 1920 by 1080, but we just can't see them? Well, can I take a screen capture? I don't know. So it doesn't really look like that fringing is happening. Right? It looks really good. Like that rendering looks very solid. To me. This guy I always noticed had a weird band on it, and I wasn't quite sure what that was. Made weirder by the fact that you don't see it on this one, even though they're the same sprite. Take a look at that. So which direction is that facing? Is that's this sprite? So I think, yeah, it seems like we're just getting basically what amounts to scaling artifacts. That could be because of the sRGB. Let me play with that a little bit. I just like to see. So let's switch down to the lower resolution. So this is like half resolution, right? And you know, we should expect to see jaggeder edges on things and blurrier imagery, but what we shouldn't be seeing is all of that fringing there. So I'm curious to know what happens if I force multi-sampling off in the OpenGL. I'm not multi-sampling. If I force real sRGB to be turned off and instead force it to use the fake sRGB. So, you know, here where we do this, I'm just going to say, you know, don't allow GPU sRGB. And so the other place that happens is, well, actually, I guess it's this whole thing. So it does kind of feel like that is what that is. So I feel like what we're seeing here is the fact that the alpha is not computed with actual sRGB, so it doesn't quite line up right when stretched. So this warrants further investigation, to say the least. I am interested to know, though, this should compute it correctly, because now if we force the shader to do the square root, that should produce roughly the same calculation as we were doing ourselves in the software renderer, which is what the art is prepackaged as at the moment in this art pack. So that sRGB computation should now be exact, right? Because what we should be doing is we should be running through shader sim, text write and shader sim text read. That is what should be happening in both cases. So every time on load and store, we should be getting precisely that same in and out that we were doing before, which is square on the way in, square root on the way out. And so that really feels to me like that should have corrected it. So I guess, and I really couldn't say, but I guess what's happening there is, my only real guess is, since that's the depth peel composite that's doing that, the bilinear filtering on the depth peel composite is therefore incorrect. Right? Because this is actually not a substitute, now that I think about it, right? Because you need to do that squaring before you blend the bilinear samples together. So if we were to just take a raw texel sample, then I think we'd actually be okay. I don't know exactly how we would do that, but it would probably look like this. And yeah, so there you go. Well, so that's definitively what the problem is with that. And what you can see there is that the depth peeling I draw this out because it's kind of tough to explain. I was trying to think of how I would say that. I couldn't think of it. So the depth peeling works by saying, okay, I've essentially got a stack of things, right? Let me see if I can draw that a little bit better there. I've got a stack of things, and I'm going to produce one of them, right? So it's going to take these, and it's going to collapse these down by blending them. It's going to take this one and blend on top of this one, top of this one, top of this one, right? Per pixel. But once you start stretching, what's going to happen then is rather than sampling right at the middle of each pixel and doing that composite once for each pixel exactly, you're actually going to pull from a bilinear sample. So you're going to be, you know, here or something. On each one of these guys is going to be, you know, a 4 sample pick. So you've got, you know, peel 0, peel 1, peel 2, peel 3. And you're pulling from the same place on all of them, but it's a blend between all of their, you know, the constituents right around there. And so when you do that, what's going to happen is you're going to get incorrect results if you don't blend those together exactly right. Because since it's pre-multiplied alpha, one of the problems with pre-multiplied alpha is it's got to be done correctly. It's got to be done exactly correctly. And if you don't actually do it correctly, you'll get too much or too little color contribution, which will lead to black or white fringing, right? Not pure black or pure white, but, you know, a lighter or darker shade around the edge of something where it should have gone to 0, both the color and the alpha, but they didn't both go to 0 at the same time. So the color went to 0, but the alpha stayed up, or the color didn't go to 0 yet, and the alpha went all the way down. And you get like a clampy edge, right? So what that suggests to me is, yeah, I don't know if we've got another bug somewhere that is contributing to that. But unfortunately, I'm not really sure that we could test it yet, because what we need is we need our assets, like our textures themselves, to properly be in actual sRGB. Because if they're not actually in sRGB, we won't be able to test what happens when the card blends them properly. So I'm not sure how we could investigate this further at the moment. I can certainly build the next art pack with proper sRGB adjustment of the pixel values. You know, that's not too hard to do. But I don't know. I don't know what I can do prior to that to analyze this any further. Now, what we can do, and what we possibly just want to do anyway, because it might be just be more efficient in the general case. I don't know, maybe it wouldn't really be more efficient. It's hard to say. Possibly not. But we might want to leave those at nearest sampling anyway, and just do a temporary, always composite to a temporary buffer. So when we do that smackdown, we would always composite to a temporary buffer on that anyway. You know, again, hard to say whether we want to do that or not, but that's certainly an option. So I think that's the tack I'll take for now, so that we don't ever stretch those buffers directly. We composite first to a final image, and then we just stretch the final image. And during that composite pass, we could also do some things like if we wanted to do some light blooming or things like that, we could also do it in there. So I don't know, maybe that's the best way to go. So the way that would work is actually this multi-sampling bit would actually, it would always work this way. So the multi-sampling part wouldn't actually happen yet, if that makes sense. So what we would do is something more like this, where we always go to a global resolve frame buffer first that we pile everything into. So this would produce an intermediate frame buffer. That frame buffer would now have the proper depth peel composite. We then switch to the thing we're going to do for blitting. And I guess, so the interesting thing about this is, does blit frame buffer support stretching? So it's just the intersection of the two. So this would not, so we need to do a second one of these passes basically where we are actually going to draw with a shader, but that shader simply doesn't do anything, right? We can't just do a frame buffer blit here because frame buffer blit is not going to, a frame buffer blit is not going to do what we need it to do, right? A frame buffer blit in this case is going to keep the size of the thing the same, and we want to stretch it. So we want to be able to take the image that we just rendered and make it larger or smaller with bilinear filtering, right? And we would even potentially, if we wanted to stretch it down a lot, we would potentially even want, MIP mapping, but I don't think we would ever do that because what we'd do is we just change the runtime size that we were rendering the game so that we never rendered the game at more than twice the resolution of the output, right? Because there's no reason to. So I think this would be okay. So what we want to do here is we want to say, all right, we did. We did this program dispatch here, and we pretty much just want to do the exact same program dispatch again, but with a slightly different program. So we would do this. And this part has to stay out for now. So I'm just going to introduce a new kind of program, which is the final stretch program that just all it's doing is that sampling. And so what we want to do here is, we're just going to do a bind texture. So here where we switch to the global resolve frame buffer, we also have to have a global resolve texture. And so all we would be doing is this, right? We would set to the final stretch program, pull from the global resolving texture, draw, and then out we go. And that's really all there is to it, I think. All right. So let's say we did that. We would then have final stretch program. There we go. And the final stretch program, I think, will just be a single texture, right? So this is the image that it's stretching. That's it. And so if I go ahead and make one of these, I think we don't really have much in the way of defines. I guess I'll leave those in there in case we want to do something with the sRGB. But for compile, peel, composite, this is actually compile final stretch. So in this case, we've got no color values, just UV. And then in our fragment code here, we've just got the image. Oops. And really, we don't probably need to do anything. So I think we're just going to do result color equals texture image frag UV, and all of this stuff is gone. So I think that's the entire program. I don't really think there's anything else to it. Yeah. So this has no vert color, right? That's not in there. Although I think we still have to get it. Let's see here. And I think that should be about it. And then we will need a corresponding binding for just that image. So when we do our use program begin here, it's always going to be slot 0 because there's only one texture. I think that's mostly it. Oops. All right. So that compiles us another program, and really it's just a pass-through program that just stretches the texture. That's all it does. Probably won't do anything else. So I don't think there's much to worry about there. However, we do need to do a slightly more delicate operation here, which is we need to create a frame buffer for that temporary purpose, right? And so what we want to do here is we want to have one other frame buffer. And so, you know, in sort of this area here, we want a global resolve frame buffer and a global resolve texture. And those need to get created at some point. So probably during initialization is when we would do that. And we probably want to just cut and paste this code and modify it a little bit. Because it's basically the same, but it's going to be enough different that I don't even really know if we can reuse the code. I suppose we might be able to make sort of an Uber frame buffer generator. I don't really know. Like maybe we can. Maybe we could do something like this where it's like allocate frame buffer or something, or create frame buffer. And maybe that's possible to just take this code and boil it down to something that just has a bunch of ifs in it, and you can pass in some flags or something that says how it's going to go, right? So for example, maybe one thing we could do is say, well, there's a GLUint for the slot, and that's, you know, note. Well, you know what? Maybe we can even make this a little bit more user-friendly. So maybe we say, like, OK, is it multi-sampled? You know, you tell us. Is it linear filtered? You know, or just is it filtered? you tell us. Something like that. And maybe I'll even make those flags just to be even clearer. Equals flags and OpenGL frame buffer multi-sampled. Flags and OpenGL frame buffer filtered. So in here we've got this glue-in slot thing, and really what I'm just going to say is, well, is it multi-sampled? Because if it's multi-sampled, we're doing this. If it's not, we're doing that, right? So there's not a lot of ambiguity there. We're going to need a struct, OpenGL frame buffer. That struct's going to have two things in it, right? It's going to have a GLUint for the texture handle and a GLUint for the frame buffer handle, right? And since we probably don't really need to call these, well, I don't know. We'll call them what they call them. So that's what I'm going to return. So I'll just say there's OpenGL frame buffer result here. And so I'll get rid of this and just say, okay, you know, glgen textures results frame buffer handle. Oh, sorry. Guess we really want to talk about two things: color handle, depth handle, right? I'll call gen textures twice because I could call it with a pointer to color handle, but you know, why be cheeky? If people reorganize those members, I would then, you know, the code would be wrong. So let's not do that. So we'll do GL gen textures, and we'll sort of allocate those two. And we can also gen the frame buffer handle as well. GL gen frame buffers, result, frame buffer handle. So that's like the first step, right? So now what we want to do is say, okay, we've got those, and we're going to need this here, like, you know, OpenGL frame buffer depth, color, equals flags, and OpenGL frame buffer, you know, color. So we could actually specify all kinds of stuff here and see which ones we're going to have. All right. So what we'd want to do here is say if color, maybe we'll say has color. If has depth, and then what we can do is sort of create the ones that we actually need. Now what's interesting about this is these are pretty similar bits here, so we really could save some code if we wanted to. I don't know that I'm going to do that right now, but I'm just pointing out that we could sort of make a texture creator call that would also save us some time, or save us some typing, I suppose, or some redundancy. But I don't think I'm going to do that just yet. But anyway, we'll get rid of this. GLBind frame buffer, global frame buffer handles, so we don't want that either. We want result frame buffer handle. And then when we do GL frame buffer texture 2D, I think but don't quote me on this, that we will then need to move this stuff up a bit. Now, I don't know if this will be valid the way I'm doing this here. We'll find out. But what I'm going to do here is say, you know, after we gen the frame buffer, we'll bind the frame buffer. And that way, when we create these, we can do the color attachment right away. That way it can exist inside the has color and has depth. And that should be pretty good. right? Okay, so we need to pass this some flags, and we need to specify what these enums are. Right, so this is OpenGL frame buffer flags. And in this case, what I'm going to do is just take exactly what I said I wanted in the code and make a set of flags for them. All right. So obviously we need the width and the height, and I might just make that be the first thing that comes down. So let's just go ahead and grab that everywhere. Oops. There we go. And same with you. And all right, result color handle, and this one is going to be result depth handle. Okay. So now we can create a frame buffer and do all that stuff. I want to have filtering be controllable too. So the other thing I'm going to do here is check that function GL text parameter I. Let's see here. There we go. And that's a GL int, it looks like. So the one that we happen to be using here is GL int. So I'm going to remember which one I think that is. So I'm going to say if we're filtered, then turn on linear filtering, otherwise turn on nearest filtering. And that way we can say, oops. On both of these, that they'll just pick up the filter type from that test and that flag. All right. So now that we could create a frame buffer, we could use this to create all the frame buffers that we currently are using, in fact, which is kind of nice, right? But the only one I want to do it for at the moment is just this one here that I actually needed. And so I'm going to go ahead and create one of those frame buffers. And you can see that we know exactly what we need for that final composite frame buffer, right, which is this global resolve frame buffer thing here. We know exactly what we need, which is something that looks like, you know, that size, right? So what I want to do here is the first time we come through, when we're doing the sort of max render target situation thing here, right, the global frame buffer count. What I want to do is when we come through here this first time, I want to create that one as well. So I want to do create frame buffer, OpenGL frame buffer. And what I want to do is I want to give it the render width and the render height. And I want to pass the right set of flags. So here are the flags that I might want. I just want it to be filtered, oops, and to have a color. It doesn't need a depth buffer. And then what I can do is say global resolve frame buffer equals resolve dot frame buffer handle, global resolve texture equals resolve texture handle. And so now I have that resolve buffer, in theory, if our routine works at all. We don't know if it does. Oops, color handle is what I wanted there. We got errors. Enable vertex attrib array. So that's just a question of that common part there doesn't have a frag color anymore. And so when we do use program common and it does this bit, that doesn't work if like one of these arrays isn't there, right? So I think what we could do in this case is if I lined these up, I could do something like this sort of thing. Which is not great. But, you know, it's good enough for now. And so I do the same thing here, because I assume you can't disable one that isn't a valid one. But we'll see. All right. So now what we're doing in this case, right, is we're doing the composite and then the stretch. And it looks like it's working, right? So that's actually pretty good, right? It looks like it's doing what we want it to do here, I think. Don't quote me on that. Like, let's actually go verify that I did enable the path correctly and everything. So here we are with the frame buffer binding. There we render the global resolve buffer, then we come through and we render a second time. And that does look roughly correct, right? That does look like, you know, what I would expect. So that's fine, and we fixed that error, so that's all good. And this means we can really just undersample as much as we want. So in theory now, you know, if we really needed to for some reason, or I don't know what the reason would ever be, because I don't know how you get a machine that had such slow graphics and such fast everything else. But you know, if we wanted to, yeah, we could basically make this even one further smaller. So, you know, if we want to do 480 by 270, oops, not by 280. We should be able to do a super blurry one. And there we go. And this would be a good test too, because we could turn on multi-sampling in this case when we get the multi-sampling working. And although it will be blurry, we should be able to get rid of all that shimmeriness, right? A lot of that shimmeriness should go away. And so that'll be a good test for tomorrow, turning on the multi-sample, right? So I think that's pretty good. I wonder. I wonder if we should just be like, hey, you know what? Let's just like, let's make this really pixelated, because why not, right? Oh, it can't. Can it not do that? What? Wait, 006. How did we end up with 0 and 0 as the render width and render height? Huh. That's pretty unusual, wouldn't you say? Oh, I never called it. That's why it's 0 and 0. So I'm interested to know if you can make like pixel hero by down like having the sampling really low and then turning off the turning off the blend. So instead of having this be filtered, you don't filter it, right? So it's like, all of a sudden, it's like a pixel art game. Not a very good pixel art game, but it's a pixel art game just the same. Right? And here we go down. You know, our pixel hero is pixeling around, doing pixel things. And, you know, that's just how that goes. Maybe that's the look you're going for. I don't know. These kids today and their pixel art, you know what I'm saying? All right, we'll do some Q&A. Okay. So John Blow has shown up, as far as I can tell, simply to say OpenGL sucks. That is it's prefixed with a Q colon. So he is not even asking the question OpenGL sucks, question mark. He's merely stating OpenGL sucks in the form of a question, kind of like Jeopardy. When it's like, this API is an agglomeration of years of mistakes. And he's going, what is OpenGL? So I guess what I would say about that is, I agree with that, obviously, but I actually like if you were to use OpenGL 4.5 like AZDO, I actually quite like. The problem with OpenGL that I find mostly is that it seems like there's people who know what they're doing, who have figured out how to actually make a good API, and they made it, and they're NVIDIA, and if you go use their extension specifically and locked just to that API, it's exactly like the way I want. Well, maybe not exactly, but real close. But the problem is that's not the reality of using OpenGL. The reality of using OpenGL is you have to write OpenGL that works on everyone's drivers. And when you limit yourself to that, or like worse yet, what I'm doing on Handmade Hero, which is kind of backwards compat, like OpenGL 3.0, so it's actually pretty old OpenGL, it's awful. And I would not disagree with that. So I actually think there is a really good API inside OpenGL, and I feel like, I don't know if that's just because there are people who kind of get what it should look like and have tried to do that as much as they can, but they only have a certain amount of influence on the committees that decide these things, and so they can't quite get there, or what. But there are some very good API design things in OpenGL 4.5 AZDO stuff that get real close to how you would want an actual graphics API to look. So I will defend that part of OpenGL. OpenGL 3.x is an epic disaster, and that happens to be what we're programming in. So there's that. And John says, the problem is there is no way for me to know what the good API is anymore. Yes, I agree. And also, I mean, I would say that it doesn't matter that you can't figure out what the good API is, because like I was saying, or sort of what I was trying to say before was, you can't really use it anyway, because you would be targeting a very small set of potential users with it necessarily. Because you might just not run on Intel at all. Like Intel GPUs are just out of the question right at that point. And AMD cards you could run on, but you would have to remove a couple parts of the API you would want or something, right? And so it's worse than just the fact that, hey, there's all this API in there that's not good and that you wouldn't want to use, but now you don't even really know that there is some good API in there that you could go use. It's worse than that, because it's like, well, yeah, but even if I told you, here's a good API, I pulled it out of OpenGL and I said, here, if you just look at these APIs and use them, they're real good. That won't ship you a game, right? So that's the actual problem. If they just like flushed the toilet and got rid of everything that wasn't basically NVIDIA, AZDO, OpenGL, right? And that was OpenGL 5, I think it would be pretty awesome, right? Because I like a lot of the stuff they did better than the way they did it in Vulkan. Because Vulkan still did a bunch of weird backwards compatibility stuff that I don't want, So, yeah. I don't know. You're damned if you do, damned if you don't. It seems like there's nowhere to go for a good graphics API. Like that's not on the table. You don't get to have that. I don't know what the best middle ground is. The only reason I program OpenGL on Handmade Heroes stream in particular is just because it's the thing that works on the most platforms. So it's the thing that probably gives people the most foothold into being able to do graphics. They could write on Android and it would look roughly like this. They could write on Linux and it would look roughly like this. They can write on Windows and it looks roughly like this. They can write on a Mac and it looks roughly like this. So I feel like that's the best thing for a teaching stream. What's the best thing for shipping a game? It seems like there is no best thing. It's like, hey, yeah, use DirectX on Windows and use Metal on Apple and use, the console-specific API that you have to use on the consoles, and use, OpenGL ES on Android, and blah, 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 blah. And it's like, well, it's just a disaster no matter what you do at that point. And so, yeah, I don't know. I don't know what to say. It's really bad. I wish it wasn't this way. I don't really, yeah. Let's see. In Win32 and in OpenGL, why do you use two different forms for assigning modern OpenGL function pointers? I using Win32 get OpenGL function macro for some, but assigning those directly. That's just because we only made that macro like part way through. So we could go back and do the other ones that way as well. We just haven't done that yet. If we were cleaning up that code, we would, because the macro is cleaner. It's easier to use and it results in less duplicated code. So, that was just because we only created the macro a little bit further on. Serial Quiller, just so you know, your stream no longer shows up in either the game development or programming categories on Twitch. It's almost a hidden stream now just for those who already followed. I don't actually know how Twitch is doing that, so I'll try to remind myself. I don't know how I will remind myself. Hold on one second. I will try to remind myself right here. Let's see. All right, I have made a note. Let's see what else we've got. I tried your anonymous union struct trick, and the compiler G++ screams at me saying I need some label in the struct name to conform to the standards, so I looked it up on Google and it appears to be undefined behavior chooses trick. Should I be afraid of that? Well, it depends what you mean by afraid. My personal opinion is that I don't really care about language specs or compliance to them. I really just care about what compilers do or don't do, and do or don't accept. So I typically just say, and this comes from two reasons. One is because I think the C and C++ specs are awful. I really just don't agree with most of the decisions they tend to make. So I would rather program in a language that's closer to what I want. And so if compilers give me the option to turn off things I just don't like I never want const strings ever. That's just not something I ever want to have, right? You know, I want to be able to turn that off if I can, and I'll program to that, turned off ability. It comes from that, but it also comes from a separate thing, which is when I was programming. Probably mid-career, I'd say. So, not when I was learning to code when I was a kid, but, roughly when I first started working in the industry, C++ compilers were so bad that they didn't obey the spec anyway. Spec compliance was not a thing that was even remotely expected, and you never got that. So, it kind of, my mental space on that is always like, the spec is not the thing I have to work with. The spec is something that is for compiler vendors and pedantic people. The actual thing that I sit down and type into is the thing I'm trying to program. And so I need to know what those are and how they work and what they create and what they accept and will do, So that's usually how I approach it. There are downsides to that, obviously, and that's if you have a compiler that can literally only accept exactly the spec, you have a problem. I don't tend to worry too much about that because as far as I've been able to tell, you can always, even if worst came to worst, you could run LLVM to transcode your thing into C or something. I'd write a text translator or something that would convert my code into something that the compiler would accept, if that's what I had to do. But I wouldn't solve the problem by ruining a good language feature that I find makes coding better just because some people who make a spec don't know what they're doing, right? Because if you did that every time, man, you'd be really unhappy with your programming. Because, there's a lot of things in the spec that make a lot of kinds of codes that you would think would work properly or should work properly technically not work. Right? That's the whole undefined behavior nonsense that you often see where people are like, what? Why did the compiler do this? And it's like, well, technically, if you add two numbers together, that's undefined behavior. So anywhere your program adds two numbers together, well, we don't actually have to add them together, right? Or, and I'm exaggerating, obviously, there for mocking effect. But, you know what I mean. There's a lot of that kind of thing. Let's see. The cursor always seems to be on the loading icon. Is there a way to fix that? I'm running into this issue and not sure if there is some Windows message I need to process. So I guess the answer could be yes, it could be no. I'm not sure, so let's just really quick check. Weight cursors are more complicated than they should be in Windows. It's a weird legacy kind of a situation. So let's take a look here. Do we even process the set cursor message? We don't. Right now, we only did that on that weird overlay window thing that Miblo made us make that time. Let's see here. So it looks like for whatever reason, so we are specifying it here, right? Here's the main window callback. And we're calling def window proc when the set cursor call is coming through. And it looks like def window proc is not, thinks we're still spinning cursor. Now, that may mean that we just should have done something else. That could mean that there's something we're not responding to that we should respond to. And I wonder, is there a Raymond Chen article on this? Because, you know, one thing we could do that would probably fix it, right, is just set the cursor to the arrow cursor in the case where we're showing the cursor, right? So, for example, here where we, you know, are passing h cursor, here we're calling set cursor 0 because we don't want a cursor at all. Here what we want to do is pass an actual cursor. So what we'd want to do is say, you know, don't do this. Instead do a set cursor here. And what we want to do is we want to load sort of an arbitrary cursor, right? We don't want to specify our own actual cursor. So there's built-in cursors you can load out of Windows. The H instance in this case, when you call load cursor, is saying, here is the executable whose resource fork I want to look at to find this cursor. We don't want to do any of that. We don't want to bundle a cursor into our executable. Like, we don't want to put an image in there, blah, 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 right? But what you can do is if you specify 0 for the H instance, you can load out of the default set of cursors. And those are identified by these IDs, right? So what you can do is you can say make int resource, which is a macro. I don't know if it's, well, we can see what it is, but we can use the make int resource macro. And we can pass one of these like the standard arrow cursor, right? And so if we do that, we should be able to set the cursor to something specific, I would think. All right, well, so that's interesting. So it works, but oddly enough, we still get a little bit of a loading thing. So there's still some miscommunication there. I wonder if we have a problem with responding to activate. Like if activate has to return true. We really should look this up because there is some set of things you're supposed to do here. I don't know. Let me take a look at what activate app expects and what activate expects. It should return 0. So that's probably not what we want. Let's see. Raymond Chen wait cursor. Yeah, we should look. I mean, I remember there being a thing, and I don't know. I don't know how to search for it. I remember there being a thing that basically said, here is what Windows looks for to determine whether it thinks your app has finished loading. And there's like, you know, there's criteria. And I do not remember what they are, unfortunately. So probably the answer is yeah. There's just something we're not responding to. Because you can see here where we actually manually said set cursor, it responded to our set cursor, but it didn't actually seem to take fully. It still thought we were loading long after there's any way we could still be considered loading, right? So one thing I do worry about here is, you know, are we actually, after create window, are we actually making our window active? Or are we somehow not doing that quite right? And so, like when we do toggle full screen here, for example, and we do set window pose, I don't know that we actually ever get the window activated in that case. So I wonder if we need to, like, you know, call activate window or something like that. What's it called? That's not what it's called, by the way. Set focus, maybe? You know, maybe set focus. So I'm not sure. I'm just going to play around with it here to see if I can poke it into submission. So that doesn't help. Neither does that. Now, one thing you'll notice is if I click, this is pretty interesting. So it's not going away from wait cursor, right? It stays on wait cursor. If I click in here, it does. So it's like activating the window somehow is not properly happening. And I'm not really sure why that's the case. Because clicking in the window should really not do anything that setting the active window doesn't do. So I'm trying to think of what it is that it's actually worried about. And we could try set foreground window. I don't know. Still no dice. And so for whatever reason, yeah, it's like until we actually do that click, it doesn't work. So I'm not sure what exactly is going on there. I could try doing it repeatedly. Like, I wonder if there's something startup related about that, but it really does seem like maybe there's a window message that we're not responding to, if that makes sense. Frosty Ninja says you can set the cursor on the win class struct with .h cursor equals load cursor 0 IDC arrow. That's true. We can do that. I would not have thought that that would be different than setting the cursor inside the set cursor call, but maybe it is. So if we want to do that here, right, oh, but wait, we are doing that. That's exactly what we are doing. When we do load cursor IDC arrow, shouldn't that be make int resource IDC arrow? Wonder if that's the problem. No. So I really don't know. I have no idea. We need to find that documentation again, is I guess what I can tell you. Let's see here. So you said the stream. Let's take the last question here. You said on the stream that you don't need header guards because you have only one translation unit. I guess you meant that you're sure you only include each header once, because even if you only have one translation unit, you still can have a problem if you include the same header twice. Well, sure, but if you only have one translation unit, it's almost impossible to include the same header twice, because you just include all the headers in one place, right? So if you take a look at handmade.h, that's where all the headers are included. Nobody else includes headers, right? So you don't have to worry. There's only one list of includes, basically. I mean, technically we've got two because the platform has some. So there's a couple in here. I don't remember where I thought they were. Oh, maybe they're not. Yeah, here. So technically there is one extra one, right? But otherwise, you've just got a list. And the same is true for handmade.cpp, right? Like, here's where all the CPP files are. So, forget headers. CPP files are the same. You can't include them twice, right? But there's no need to put an include guard around them because you're just going to list them. There aren't going to ever be any other pound includes. You're just going to list all your pound includes in one place, and that's done, right? That's completely done. So yeah. I think that's it. And Nicholas says, Casey, I asked about multiple anonymous unions. Yeah, but I'm not sure. I thought we covered that, although maybe I'm missing something. I mean, I guess I don't know what you mean by multiple anonymous unions, but oops. But if you look at like Handmade platform, where's our v2 at? Here we go. So here's an example of multiple anonymous structs inside something, and multiple anonymous unions inside the structs, but not on the outside of the structs. I don't know if you're talking about something other than that, but that is, we do multiple anonymous all the time. Multiple anonymous is a very common thing for us to do. So, all right, let's wrap it up. Wow, no. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it. We also have a forum site you can go to if you want to support, if you want to ask questions, a Patreon page if you want to support the video series, a schedule bot that tweets the question, the schedule at you if you want to know we're going to be live, and an episode guide that helps you catch up on old episodes. I also wanted to take a moment to announce that there is a new supportable project that is related to Handmade Hero, and it's actually kind of exciting. There's a couple of these kind of going on, but I don't know of any other ones that are supportable at the moment. So let me go ahead and show it to you. It's on Handmade Network, as a lot of those projects are. What you can see here is a embeddable debugger that's being worked on, and the idea is to, instead of having, a particular debugger that you have to use and it's like, oh, it's Visual Studio or whatever else. The idea is to build sort of a debugging library that you can use where if you want to put a debugger into something else, right, like a text editor that you particularly like that happens to be customizable, say 4Coder in my case, you can use this library to quickly add debugging features to that existing editor. And so this is really exciting because if this worked out and we had a good library we could use for debugging, we could completely get rid of a lot of the stuff that we are currently using, like GDB, front ends, and Visual Studio, et cetera, et cetera. And so I would love to see a project like this come to fruition where there's like a clean, good API library for debugging, and so everything that we might want, we can stick a debugger into and have good debugging facilities would be pretty awesome, right? And it would also be part of the sort of the Handmade Network school of thought there, so it would actually be something where it cared about how the API was. It would be easily usable without installing Python and all these other sorts of things, or who knows what the typical kind of thing that you expect when you install a library or try to use a library, right? I can't say much about it yet, because it's still pretty early in development, but it is kind of a really interesting potential project. And so if you're interested in that, it does have a Patreon. I don't know what the easiest way to get to it is. Probably just doing like what I just did. But what you can do is you can go to this Patreon and support it, and that would presumably really help the project out, because if this number got higher, a lot more time would get spent on it. It's probably easiest to get there by just putting lysa.handmade.network. But I also assume that if you just were on Handmade Network, you could also probably find it. In fact, there it is on the front page right now. But it would be under the project section, so you could find it in here if you forgot what it was called or something like that, right? So yeah, just wanted to bring that to your attention, because I know that a lot of people have been really good about supporting stuff that we use on Handmade Heroes. So for example, 4Coder is now very well supported. And that's really awesome, because I rely on it every day, and so I support it, and I, very much appreciate that other people support it, because it means that we have a really good editor now, which I never had before. I had to use Emacs before, and it was not very good. So, if we can get a few more projects like that into position where it's like, these are really good alternative development tools that are, high quality and that we can use, I think that's pretty awesome. So hopefully you'll check that out and see if it's something that you might want to support or be involved with. That's about it for this weekend. Today. I guess I'll be back here tomorrow. Sorry, I haven't had coffee yet today, so my brain's kind of scattershot. I'm surprised the programming went as well as it did. Anyway, I'll be back here tomorrow, and we'll take a look at doing some multi-sampling so that we can get rid of some of those jaggies. And we're pretty good on artifacts now. There's very little artifacting in the depth peel rendering, so it's pretty good. I'm feeling very good about the renderer. We might have to take a look at making sure that like our cutscene stuff still works. But other than that, I think we're in pretty good shape. And we can do some more cleanup maybe the weekend after, and give it the official seal of approval that that's the renderer, and off we go. All right. Thanks everyone for joining me. I'll see you back here tomorrow. Till then, have fun programming, and I'll see you all on the internet. Take it easy, everybody.